Hello and welcome back to part 2 of the RCA U42 video, the precursor to tuning up the Howard to FM converter. It's been almost a month in making this. I've had problems with the software, which I finally straightened out and got that taken care of. I've had a lot of other things going on, getting the cars ready for inspection, helping my sister out with my handicapped sister. I don't know how I ever found time to work. I'm so doggone busy in my retirement. It's incredible. Excuse me. But I do want to thank all of my viewers who commented on my last video on my return from Thailand. It's nice to see you guys out there, see that you're still watching. I really do appreciate it, and I gotta tell you, it brought a tear to my eye to know that you guys are still out there and loyal viewers. It made me feel really good. I didn't think it was going to affect me as much as it did, but when I read down through all of the comments, it just really touched me. So thanks, guys. I really do appreciate the support, and I really do appreciate hearing from you. It makes it worthwhile. You guys make it worthwhile, and I know that sounds like a cliche, but when I get nice, the nice comments and the reviews, it makes it worth the effort it takes to make these videos. And anybody who's done these knows how much work these are. They look simple. You get a 15, 20, 25-minute video, and you think, big deal, 20 minutes. This has been a month in the making, and you probably notice I've had different shirts on and different segments and different clothes on. It's because it just takes an inordinate amount of time to do these sometimes. Anyway, thanks again, and on with the video. This is the AM antenna for the receiver, and I'm shooting this a little bit out of sequence so that I can take this out and repair it. But basically the way it works is we have many turns of wire around the outside here, and they're tuned by the tuning capacitor inside the radio itself to bring this into resonance. The problem with this is it's getting on in years and coming apart, and I'll try to show this a little more clearly here. This got wet along with everything else, and I'm not sure how well this is going to translate to the video or to the camera. This probably shows up fairly well. You can see the wood, the plywood that this is made out of, is pretty much just falling apart. All the glue has failed due to high humidity. And same thing here. If I put the screwdriver down in here, I'm hoping this is in frame. I'm trying to do this. Yeah, there we go. Get my hand out of the way. This is completely falling apart. What I'm going to do with this is use one of these syringes. You can get these things on eBay. They're pretty inexpensive. The needles come off. You can put any size needle you want on here. These are not sharp. These are not drug needles. These are industrial epoxy dispensing needles. But you draw up some wood glue and then put this down in between the pieces of wood that are coming apart. You can slide it right down in between the wood, inject your glue inside there, and then I'll put some metal plates on both sides of this and clamp it and let the glue dry for 24 hours or so, and when I get finished it'll be as good as new. The only thing holding this together now are these tie bars that the wires are wound on, these phenolic or whatever they are, some sort of fiber board. That is what the shelf for the power supply looked like when I got this radio. And let me turn this around again, try not to make you too dizzy. Going a little bit fast here. We'll swing this thing around, and we've got the radio turned around. This right here was in the same condition, and I glued that back together, and I can stand on that now. That's just as solid as can be. And that is actually in there. I don't know, you probably can't see it, but there's tongue and groove. There's a groove in the front board, and when I replace this piece, this piece had completely fallen apart and there were pieces missing, so I had to cut a piece of plywood. And I put a groove in the back with the table saw so that the tongue on this piece fit into here, fits into there. There's a glue block underneath on both ends. That's just as solid as it ever was, or probably, you know, as solid as a brand new piece of wood, but it's the original. And we'll come back around here for a couple other things. Somebody, I don't know if this is factory or not, somebody at some point, I think, did a repair on here, and or something I could stand underneath this. This ought to work. There we go. We have some spreaders here. Now these were added, I think, afterwards. I don't know, this may or may not be factory. These on here and here are definitely factory. The one on the end, the middle one, and this one. These I'm not sure about. These may have been added at some point in time. The adhesive or the glue used on here is obviously horsehair, or not horsehair, horse hoof glue, horse glue, wood glue, very common. My father used to use that. You have to heat it in a pot. These wires were in horrible shape. They were all bent out of position. And I was trying to find some more of these wooden dowels that, like they used here, to use here. And I looked around, didn't have any luck. And then today, I was in the grocery store doing some shopping with my mask to keep the coronavirus, the CCP virus, at bay. I found these. They're skewers for cooking, and you can get these in 3/16 of an inch diameter, which is what these are, or these were the original ones. And am I still in frame here? Yes. And these are 1/8 of an inch. Now I didn't need the 1/8 of an inch ones, but I did need the 3/16 of an inch ones to match the ones that were on there. So I figured, what the heck, they're cheap enough. I'll throw those in the toolbox and hang on to them. They'll come in handy for something. And I'm shooting this a little bit out of sequence because I want to get this thing down in the wood shop and glue this back together and make this thing solid again. Like I say, the only thing holding it together at this point are these strips here. If those weren't there, this would have fallen apart long ago. So there's a couple of tricks. If you have a radio that has one of these antennas in it, you can, and it's coming apart, or anything plywood like that coming apart, you can inject some glue in between with these syringes, and again, just, you know, regular wood glue, white glue. This will draw it in. You put it in a little pot of glue and pull the plunger up, it'll draw it in, and then inject it in between the boards. And I believe I've mentioned this before, and we're going to swing back around. There we go. How's that for getting dizzy? I hate handheld camera shots, but I'm going to do one for a minute here. I hate it when people do this, but here I am doing it. If you have a veneer like this that's coming apart, and let's say it's solidly glued around the edges, but you've got a big bubble in the center because the veneer has lifted due to the humidity and so on and so forth. What I do is I mic the board. I find out how thick it is and take a stab at how thick the veneer is, and I'll drill a hole underneath, or several holes underneath, through the backing wood, stopping short so that I don't bust through the veneer. And I'll use that syringe, I'll inject glue from the back side, and it will be underneath the veneer that way. And then I'll put either a good flat plywood plate on both sides, or a big enough, if I have a big enough metal plate, I'll put it on there and clamp the daylights out of it. And if you do that, you can save the veneer. It'll glue it back down. It'll be just as good as it was before originally. Through the magic of YouTube, we have our antenna glued back together so that the plywood frame is now solid as it's meant to be, good and rugged. we have added the spreaders here that kind of mirror what was on there originally. When I put them on there, they were very, very white in color compared to these, so I just splashed a little bit of black dark maple stain on them just to kind of tone them down a little bit and make them look more like the ones that were on there. I have no idea if these are original or were added later, but they stiffen the wires up nicely and allow you to run them fairly straight, because in this area here a lot of them were overlapping. The beauty of these antennas is they're directional, and they're directional in this direction. You can peak on your station by turning the antenna, and in this direction it will be peaked, and anything from this direction will be somewhat nulled. Let's see if we're in frame here. Okay, so anything from this direction will be somewhat nulled, anything in this direction will be peaked. And they're great if you have noise, neighborhood noise, or something very noisy in your neighborhood. A lot of times you can turn them and find a good compromise between nulling the noise and peaking the signal that you're looking for. At any rate, that's fixed. Then I decided to do some more playing with this guy that needed attention while I was working on this and doing alignment. Was this loop antenna that is for the shortwave bands. This to me almost looks like it's homemade, like somebody made this and put it in to replace a missing antenna. I've never seen the inside of one of these sets before, so I don't know if this is original and somebody just put a coat of paint on it or what. The problem was, during the alignment, this is supposed to be peaked with a trimmer on the back of the set at 15.2 megahertz. The trimmer on the back wouldn't pull it in. It wouldn't even come close. There was no way I could find a peak. So out of curiosity, I took my network analyzer, and swept the antenna plugged into the set, and it was resonating somewhere in the neighborhood of 12 megahertz. And whoops, yeah, it's going to slide. I'll put this right up on the screen as well. Probably, in fact, I should just put it on the screen. But the red line that you see here is where it was peaking as it was in the set. Way too far below the 15.2 megahertz to be pulled in with a little trimmer cap. Since I had the unit and, didn't feel like building something right now, or until I find out if this is really the right one anyway, and ignore the band C stamp on here. That's something I put on there, so it made it obvious which connector to plug it in. They're both 3-pin connectors. I added a series capacitance, and I just went downstairs and I said, I'll try 120 picofarad and put it in series with it and see what happens. And bang, it came up with the peaks, or the resonance points you see on the blue lines, the upper blue line here. And one of them fell at 15.8 megahertz, which is close enough for the trimmer to pull it in to 15.2. I had no problem at all pulling that in and getting a peak at 15.2 megahertz. So for the time being, I'm just going to leave it in like this as it is. Now, this is supposed to be done as well as the peaking of the AM antenna. They're supposed to be done in the cabinet so that there's no metal around them and everything's in its operating position. So I'll be doing a final alignment on the AM antenna on this once everything is reinstalled back at in the cabinet. But this never worked correctly, and I always had to use an outside antenna for shortwave. Not that I ever use this really for shortwave. I just like to have everything working. So there's another item that we got out of the way, and something else that got worked on during the changed during the alignments when I was playing with it. There's a 6K7 IF amplifier tube in here. I can probably flip this up right here, and it was a metal tube, and it was it was weak. It was down near the questionable area on the tube tester. Now it was working fine, and for as much use as this set's ever going to see, it would probably last another 20 years. But I had a box with about 10 of these in it, and I said, I'll pull a couple of them out and test them, and just put a better tube in. I had plenty of them. So I put one of the very nice Coke bottle style glass Coke bottle style tubes in there and tried to do an IF alignment, and couldn't do it. The ABC kept locking up on me, and what I mean by that was I'd start to tune the IF and the tuning eye would snap open, fully open, and the ABC voltage would nosedive. And I said, that's breaking into oscillation. And I discovered when I got anywhere near this IF can, it would affect the tuning seriously. Now, some of you may have noticed at one time this was over here because it's got the slot for the grid cap wire. But I took it off of here and put it on there, and things immediately got better, but I could still break it into oscillation when I peaked up this IF transformer. So I went back in the box and I found another one of the metal shielded or the metal style 6K7s and put that in, and the problem went away. Now, as you've probably seen in a lot of old sets, a lot of tubes in the RF and IF section have metal shields on them anyway. So if you have the IF, or if you have the tubes with the metal shielding on them, they're a good tube to use in the IF because it offers a lot of shielding. Let's see. Let me get set up for this next shot. In the schematic here, we have our push-pull output, our phase inverter, and our detector tube. First audio amp, detector tube, phase inverter, push-pull output. And here, and here, as well as, let me find the little rascule. There's another 0.01 here somewhere in the volume control circuitry. Dun, 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 dun. Let's see, we come out of the detector. Oh, nope, that's a 005. Anyway, in here somewhere there's another 0.01. While I had it apart and I was tinkering in there and changing caps, I said I'm going to do a little experiment just for the heck of it. It was easy enough to work on this set, plenty of room underneath there. Instead of using your normal coupling cap, I figured I'd give one of these disc ceramics a try. Now, you shouldn't use these in audio chains, that's a well-known thing. They're a little bit microphonic. They tend to have strange resonance points. They're used for RF bypass. They're very lossy. They're designed to bleed RF to ground, like off your AVC line or out of your audio chain to ground. That was their intended purpose, a disc ceramic. But I figured I'd give them a try. And while I was at it, I also tested them using my Q meter. Now, a Q meter is a device that tests the Q or quality of a component. It's what's called a valueless number, or valueless, what's the word I'm searching for? It doesn't have a reference point like ohms can be related to a column of mercury that's about 1 meter tall, and an amp is 1 ohm or 1 volt through 1 ohm. So you have definite points you can calibrate to, but a Q does not have any actual reference point. What it is a comparison, an A-B comparison. They have a parallel tuned circuit, and you put your component in and tune it to resonance and measure the voltage across the tuned parallel pair. And the higher the voltage at a given input, the better the Q, or the quality of that component. In other words, it's handing back more energy. That you put in energy and it hands back more energy if it has higher Q. I hope that makes sense. Basically what it is, you get a better return on energy put in with a high Q component than you will with a low Q component. This had a Q of 35, and if you take a look at the picture of the Q meter here, you'll notice that the times 100 button is pressed in, and look where the needle is. It's about 35 Q. Then I put in this orange drop, and I had to go up to the next range. I had to go up to the next higher range, which I think is 300. I'll have to look at the video as I do this. And this one registered a Q of 110. Certainly a much better component and much more suited for coupling. These are well suited for bypass. These are better suited for coupling in between stages. But I put them in there. I wanted to see how they would perform. Now this radio has, right here it says 6K6 and there's an asterisk right here. And down below it says on some units they have 6F6 tubes. I had 6K6s in it, or excuse me, 6F6s in it when I got it. It had 6F6s in it when I got it, not the 6K6s that the schematic calls for. Easy for me to say. Powered it up, turned it on, and connected a sine wave generator at 1 kilohertz and put my Hewlett-Packard harmonic distortion analyzer on the thing, and I was getting about 12% THD at full power, which was around 12 watts. Now it's strange, the thing says it's only good for 6 watts, but this will actually put out about 12 watts before you start seeing visible distortion on an oscilloscope. At any rate, the 6F6, even when I reduced the power down to 9 watts, was 7% total harmonic distortion. No, excuse me, let me back up here. I'm screwing up. It was 12% harmonic distortion. I rolled it down even at about 9 watts. It was still about 10 to 12% harmonic distortion. Now if you look at the schematic here, the phase inverter uses a voltage divider here. There's a couple of resistors to balance these the drive on these two tubes. Resistors are going to drift, tubes are going to change. Look at some, no two tubes are going to age exactly the same, and you're going to end up with an imbalance, and you're going to get crossover distortion where one part of the sine wave meets the second part of the sine wave for the push-pull circuit. You'll end up with crossover distortion. So I said, the heck with it. I've got the thing all apart. These two resistors here total up to about 500K. So I put a 500K pot in the unit right here. Let me see if I can get a little more light on that. So I installed a 500K pot right here in place of those two resistors. And I did a little tweaking. I went from 12% distortion, just that tweak brought me down to about 7% distortion. Then I said, okay, let's find out what the impedance of the output transformer is. And I have an impedance meter, an audio impedance meter, and I pulled the transformer or the wires off the transformer, and I checked and made sure I had the right impedance load on the other side of the output transformer. It says here 2 ohms. Where is it? Somewhere on, in the parts list it says it's a 2 ohm speaker. That's a lie. It's a 4 ohm speaker with a 4 ohm secondary on the output transformer, and I verified that a couple times. So I put a 4 ohm load on it, non-inductive 4 ohm resistor, and measured the primary impedance, and they're a much better match for a 6K6 versus a 6F6. So I replaced the 2 tubes with 6K6s. I took the 6F6s that were in there out and put the 6K6s that are listed on the schematic. And again, the schematic says you can use 6F6s. Immediately my distortion dropped to about 4 to 5%, depending on whether I tested at 400 Hertz or 1000 Hertz. So I said, okay, we're making some progress. How much better can we do? Then I took out the ceramic discs and I installed the orange drops as my coupling caps at the 3 points that I mentioned, the two grids on the 6F or 6K6s, and coming out of the detector into the volume pot. And lo and behold, once I'd made that change and tweaked that internal pot again, at 12 watts it was 3% distortion. So pushing it as hard as I could before I saw visible distortion on an oscilloscope. And again, you can't really see distortion on a scope unless it gets really bad. But I could see the distortion. I could actually, when it started to clip, I'd back it off about a volt. And I had 3% distortion at 12 watts. At 6 watts, it dropped down to 0.75% distortion. At 3 watts, it was 0.6% distortion. And at 1.5 watts, 0.36% total harmonic distortion. Now, I tried dropping lower, because even at a 3/16 of a watt, 0.187, it's still fairly loud. I mean, you're still getting 100 and something milliwatts out of there. It's fairly loud. 187 milliwatts, as a matter of fact. And I said, wow, that sounds pretty good. The thing is, I couldn't give you a total harmonic distortion reading on here, because when you do, or when you use one of these, you put your signal in here, you put this to set level, put this to set level, and you adjust the sensitivity for a full scale reading on this meter. Then you set this to distortion and do your tuning and measure your distortion level. The needle wouldn't go beyond about half scale when it was at the lowest power setting that I had there, so I just let it go. I said it's pretty good at 1.5 watts, 0.36% distortion. I was perfectly happy with that. So there's another lesson. If you're doing coupling, use a quality capacitor. Don't try to get by using disc ceramics. They introduce a lot of distortion. Okay, what else are we going to talk about here before I shut this down? I don't know how long this is running. I'll have to take a hard look here. I'm going to take a look at this. Wasn't something that was wrong with the set. I just found it interesting. I had never seen a capacitor like this before. It appears to be two silvered metal plates riveted on, or the leads are riveted on, and there's a little slice of mica in between. This is in the oscillator for the shortwave band. This one here is for the AM band, and the one in the back that's marked 560 picofarads is for the shortwave band. And just out of curiosity, I took it out and put it down on this capacitance bridge that you see here, and it measures 564 picofarads. So the capacitor is in good shape. I checked it all out. There's no leakage. It's out in the open, all exposed. The oscillator runs fine, so I put it back in because it's such an interesting looking piece. And again, since the oscillator for the shortwave band works fine, I figured I'd leave it right in there. It's not leaky. It's not likely to leak. It's just from its construction. It's probably going to outlive me and you and whoever else gets this radio in the future. But I had just never seen that style of capacitor before in a radio, so it was interesting. And yes, I know it's 564 picofarads because this bridge is absolutely dead on the money. I have several standards that I check it with periodically, and I can measure down to like 1/100th of a picofarad with this thing. It's, I don't really need that kind of accuracy, but it's just kind of fun once in a while to throw something like this capacitor in there and find out how close it is after 80 years. Okay, and just to prove this thing actually works, we have it turned on here.
American ingenuity at its best as we begin the process of safely reopening. Straight ahead. This is News Radio
610 and 96.7, New Hampshire's news, traffic, and weather station, an iHeart radio station. Now, New Hampshire News.
Sunny today, high 70. Cloudy tonight with some showers around late, low 52.
And I'm just going to turn that off because it is so noisy here in this house, in this lab in particular. There's so many different power supply, switching supplies, fluorescent lamps, yada yada yada. And I am in a valley here, I'm in a hole, and I only get that one station extremely strong. Unless I put up an outside antenna. All my other AM sets, it's basically a one channel wonder when you're in this area. There's a couple others I can pull out once in a while, but they're so noisy because of all the background noise that's around here. But the radio's not sounding bad. It still sounds a little bit constricted to me. I would like to have it sound a little better, but again, this cone is just incredibly stiff. It's I keep saying this, but that's got to be the stiffest suspension I've ever seen. The thing is just unbelievably stiff. It's going to sound better, of course, once it's installed in the cabinet. It'll add a little bit of bass, but it's already kind of bassy. So, yeah, it is what it is at this point. Speaker technology has certainly improved greatly over the last 80 years. However, I think I am going to try one more experiment with this, and I don't think I'll get it into this video. I'm going to move some more test equipment in here, and I am going to try stagger tuning the IFs on this. You don't have an awful lot of bandwidth to work on, audio bandwidth on AM as it is. If those two IFs are very sharply tuned, I have no idea how sharp they are because I haven't swept them. All I've done is the standard signal generator, voltmeter, alignment, peaking the two or the four adjustments on the two cans. I am going to take a sweep generator. I'm going to try taking a sweep generator and see if I can fatten up the IF curve. In fact, this is left over from one of my previous videos. When you tune, it's too slippery here. Way too slippery. We'll put this guy down here. When you tune an AM radio, typically all you do is peak the IF curve. And whatever it is, it is. And your 3 dB points fall wherever. When you tune an FM radio, you typically broaden out the curve so you can get that wide bandwidth of about 15 kilohertz, so you have some fidelity on your FM, and typically you end up with a little dip in the center. I know I'm not going to get it 15 kilohertz wide, and I wouldn't want it that wide, but I'm going to see if I can open this up to maybe, instead of 5 kilohertz, 8 kilohertz wide, and see if I get any improvement. But I'm going to either do that on the next video. We'll see how long this one is when I finish editing. I don't want them to run on too long. So for now, I am going to take this down to the editing bench and start putting things together if I can. We'll see you again soon.